Okay, so now we are on the parametric section, and then we now have a softball problem. So the problem says, Katie is playing softball at Clayton High School. After 2 strikes, Katie finally hits the ball at an initial velocity of 100 feet per second at an angle of approximately 60 degrees to the horizontal, and she makes contact 3 feet above the ground. The outfield fence is 225 feet away from home plate. I should probably add that in there. 5 feet away from home plate, and the fence is 5 feet tall, which is over here. So the first one is saying find the 2 parametric equations to model the path of the baseball. So the x component is just the velocity, and then x is always going to be cosine, so the cosine, and then you do the degrees to the horizontal, so you do cosine of 60 degrees times t, and t we don't know. So then y we do, so we have -1/2. It's usually gt squared, and g is for the gravity. Gravity is always, when it's in feet, you have to do 32, so you do 1/2 of 32 t squared plus, and then you have the 100, and since this is the y component, we do this 120 sine of 60 degrees, and then t, it's basically, this part is like basically the same as that, but you have to consider like gravity and stuff, because it's the y component, so the gravity is pulling like the ball down. And then after the t, you have to add 3, because Katie is 3 feet. She makes contact 3 feet above the ground, which is why you have to add 3. So the next question is asking, where's the ball after 2.5 seconds? So that means that we have to plug in 2.5 seconds for t into the, we're going to plug it into the x equation. Because it's asking like, where's the ball? So like, how far has it traveled? And so that's like the x component, like, so which is why we're plugging into that. So then 100 cosine 60 times 2.5. And then when you plug that into your calculator, if you're in the right mode, you should get 150 feet away from home plate.